This tutorial is going to talk about polar line equations. If you haven't already looked at the tutorial for line equations, which are defined in Cartesian coordinates, make sure you look at that one first, because this one will just follow on from some of the things that are described in that. So now if I add a polar line equation, or line equation polar, it's very similar, but now we have to define our formulas for angle, radius and z instead of x, y, z. So if I have a x center, y center of 100, and the angle is going to go from 0 to 3. So this is in radians, so it wouldn't go from 0 to 360, it will go from 0 to 2 pi. That means it's going to go to do a full circle of 2 pi being a full polar completed circumference. So if I do, my t value is going to go from 0 to 1, as I kind of recommended in the Cartesian repeat one, and then the angle formula, if I do that from t val times by 2 times by pi, that means it's going to go from 0 when t val is 0 to 2 pi when t val is 1. So that means our angle is going to do a full circle, or a full circumference, as we go from t, go through all the t's. I'm going to set z form to be 0, and initially I'm just going to have a radius of 50, and number of segments, I'll do it. I try to do this in nice neat divisions, so I have kind of 6 segments per 90 degrees or something. So if I do 128, that means I have a fairly neat looking symmetrical structure. And then 0.5 and 0.2 for our height, and then I'm not going to change e or speed or tool number or anything at the moment. So that should give us a circle. And there we go. It started at a polar coordinate of 0. The angle increased to 100 to 2 pi in radians in 128 segments. And that was that. So then if I changed my angles, so let me put the line equation polar down here. So if I change my angle formula to be 0.5 times by that, now it will only do half a circle. And if I change my radial formula, instead of being 50, to be 50 minus t val times by 50, then it's going to start at 50, end at 0, so it should do some kind of like spiral inwards, like that. And instead of it just coming in, I could do this as a sine wave. So if my radial formula is going to be 50 plus a sine wave of t val. So as I mentioned before, we can do t val times by 2 times by pi to get a full sine wave occurring. And what I actually do is often I'll create a parameter for this, where here I'll put pi underscore 2 and give it as a value of 2 times by pi. And then if I click assign parameters, now we've got a parameter for pi 2, and I can just put that here, which is a little bit easier with 2 brackets. Now, unless you put an equal sign at the beginning of your formulas, Excel won't help you out. So now I've put an equal sign, it's now suggesting the parameters that I've told it about. So t val times by 2 pi. So now it should be a sine wave with an amplitude of 1, fluctuating about 50. So I'm going to increase its amplitude, which in this case I'll just do 10 times pi. So it should move to be 10 greater than 50 and 10 lower than 50. Okay, so it looks a bit odd, but it's probably doing what we want. If I do it as a higher frequency, then it will be a lot easier to see. So to increase the frequency, you put it within the brackets of a sine wave. So if I do 10, so now it should do 10 sine waves, and now it's a lot clearer to see. I'm going to show you then one of the issues I was talking about. You can see these have slightly different shapes. This one has the point nicely defined, whereas this one doesn't. And that's because I've got 10 sine waves. So I'd really want a kind of multiple of 10 here. So actually, it really depends on your formula. But if I put this to 100, now every sine wave will be symmetrical, will be the same as each other. So you can see they're all nice. And we haven't got them at a point yet. So if we wanted to get it to a point, we could, at the moment I've got 10 segments for each sine wave. So if I think for each sine wave I want to have 12 segments, that would be nice, because then we have 3 coming up to the tip, 3 coming down to the middle, 3 going up to this tip, and 3 down to this middle. So I want 12 segments. So 12 times by 10 is going to be 120. And that should give us a neater image. And as you can see, that's what we've got. And of course, increasing the number of segments. So if I do this as 240 or 480, then it will be much smoother. So the rest of the stuff I think I've covered in the tutorial for normal line equations, and it's very similar here. You're just defining the equations for the angle, radius and z instead of x, y and z, and everything else is much the same. You can still do different formulas for width, height, e override to override these two, or f speed. And similarly, there is the option to do a repeat rule with offset polar maths. So by adding the repeat rule with offset polar maths, we now need to define the x center, y center, and then a formula for how much each repeat is varying in terms of the angular displacement formula, radial displacement formula, and z offset formula, which I'll discuss in another tutorial.